I think will start to change the way that people and businesses use AI and build their speech AI capabilities. And what that unlocks, I think, is like that's like the LLM, the AI whole story is that it's always a surprise what that unlocks in a lot of ways. You just don't know what does that shift from 1.5 second response to a 300 millisecond speech response. What does that unlock? I genuinely don't know.
I think we are seeing speech having its moment, which is why we're focused on it.
Everyone in this space right now is kind of talking about 2026 as it relates to voice AI as the year it's becoming infrastructure.
ChatGPT was such a revolutionary moment because of the brains, right? You could speak, you could use natural language for so many different and new kind of use cases. Speech is kind of lagged. People that are using it for speech use cases often didn't get a ton of value out of it. But now new open source models are coming on board. The underlying models have continued to progress. And so these speech capabilities have really come along. And now we're riding that same sort of wave where you have to graduate, right? You have to have a certain level of competency and skill and capability on the model side to unlock new use cases. A lot of the tooling is primarily built to service these sort of text in, text out applications. And so when you start dealing with different forms of media, whether that's images, or documents, audio, the underlying technology for inference changes. And there's different kind of performance requirements. So, on an audio file, it's a much larger data set. Text compresses really well. It's small. You get a lot of information in text without having to store a large file. The same isn't true for audio and video. And video will be coming as well. But that step change, both in the level of maturity for the inference infrastructure, which has historically, again, been focused on text, and then the size of the data that you're now operating on changes the sort of technical problems that you have to solve on the back end. And so vLLM-Omni is building on top of VLLM. VLLM handles audio input and output for certain use cases, but bringing them all together in a multimodal use case where you're dealing with video potentially inline with audio, producing different types of outputs based on a collection of inputs, that is really new. And the inference, both in the software stack that you use to run it, and then the way that as a piece of infrastructure, we have to provision our kind of GPU allocation on the back end to maintain headroom for those different kind of user inputs also changes. So like a lot of the fundamental engineering constraints are just shifted enough that it's not one-to-one applicable. The lessons you'd learn for text-based serving are just a little bit different. So OpenAI is going to do this, and they already do this. But if you're a different sort of enterprise, if you're either a provider like us or an enterprise trying to roll out their own models on top of open source, there's just a bunch of different skills that you have to develop and in-house to do that efficiently.
So what is Sprag and who are the two of you?
So Sprag is voice AI built for speed. We're focused on building on top of vLLM-Omni to serve inference 3 times faster than ElevenLabs and Cartesia. I'm currently the interim CEO of Sprag.
I'm Ian. I'm the CTO. I'm kind of a serial founder now. My background was in computational physics, but I kind of ran machine learning organizations everywhere from startups to Fortune 50 companies. Did that for about 10 years before I started my own company. Went through YC. It was a data engineering and infrastructure company. Shifted over to some of the AI developments when that ChatGPT moment arrived. So Sprag for us was kind of an opportunity because of this transition that we're in. This transition in multimodal serving and infrastructure. The release of vLLM-Omni, and now some of the others, so like SGLang has their own Omni service. This is like a big change in the industry and a big change in what the stack is going to look like moving forwards. And really, we saw an opportunity to support businesses in particular who are building AI on top of these, because despite the fact that GPT-4 maybe was a disappointment for some people, that's not going to be the case moving forward. So model releases like Qwen 3 Omni have really changed the capability set. So for us, we have users who are trying to deal with multilingual kind of corpuses or product domains where you have a user who's switching between different languages on the fly, and you need a more capable model than most traditional ASR approaches have been to accommodate that sort of complex linguistic domain. And so that's one of the things that now we handle on Sprag with Sprag by providing larger models, more capable models that can deal with all of these different kind of sensory inputs at the same time. And so that's kind of one of the places where we saw immediate opportunity, but there's a broader industry change that's happening as diffusion and multimodal serving also come into their own.
Can you explain more about that, like what you just said, the differences in the multimodal, and is that different from diffusion?
Yeah, well, so let me start with multimodal because I think that kind of grounds a lot of what we're doing. So diffusion is, I think, for us, supplementary. So multimodal, most models we're serving are still autoaggressive transformers under the hood. But diffusion is just a different style of model that one can run. And vLLM-Omni in particular focuses on bringing both the capacity for multimodal inference and diffusion model serving to the vLLM orchestrator. So in that sense, they're complementary for us. We build on top of vLLM-Omni, and that means we can facilitate inference for both model families among our customers. But they're sometimes they coordinate. The way multimodal works, if you compare it to a traditional autoaggressive transformer model, is that there's often stages that are performing different functions as part of that multimodal inference component. So you might have a thinker that's dealing in text-based inputs and outputs, and a speaker. And these are different kind of chunks of the model that are focused on producing artifacts of different modalities. vLLM-Omni exposes a staged graph for coordinating between these different components, so that the thinker can think in this abstract way and hand off a component of that thought to the speaker to begin working on generating a text output as a result. And so this kind of staged graph allows the two to coordinate in a way that traditionally what we've had to do is almost sequence them. So you have a text output, and we'll see this in text pipelines that people currently use. You have a text output that gets written into plain English or whatever other language that gets handed off to a text-to-speech model to generate output as a result. But it means that the first one has to fully finish before the second one can begin. And so one of the advantages is now that through Omni, you can coordinate these pieces more efficiently. And you get faster inference and oftentimes better inference as a result. So that's kind of one piece. The second question, I think, was more about what are we doing in that space, and maybe to some extent, why are we focused on voice? Well, and I think, like you said, we are trying to ride a wave to some extent, because in this broader multimodal universe, there's really going to be an enormous number of use cases that come out of it. Video is coming down the pipe. Audio is coming into its own this year. Text is already here. We are an inference stack that's built to handle all of those. And looking forward to robotics, for example, world models that are doing real-time forecasting or of a sequence of events, like that's a video output for the most part. We would serve that on the same basic stack. But audio is a place that's seeing a lot of value creation right now. And so that's one of the reasons we're focused on it. Traditionally, people have built kind of pipelined models where they say, you have a speech to text, the user speaks, it's transcribed to text. There's an LLM that sits in the middle that's kind of the brains of the operation. It performs whatever task. Maybe it has to do tool calling or something along those lines. The output from that gets handed off to a text-to-speech model, and the speech is finally streamed back to the end user. So that is still, that's still how people run most of these pipelines and most of these systems. There are alternatives that are kind of natively agentic, is how I think about it. The user speaks and the model natively deals with whatever it has to do, including tool calling, to produce a speech output. And that's one of the things that we serve. And because we're built on top of Omni, it means that we can serve that really, really efficiently and really, really quickly. So that kind of coordination piece I was talking about earlier is essential to how that gets accomplished. But even with traditional pipelines, we have, going back to the multilingual use cases, we can use these multimodal models that, again, are really fast because of the inference stack that we serve on top of, but that are bigger and smart enough to understand like the more difficult context of a multilingual use case, where somebody is maybe code switching between English and Urdu or some other language. So that's, I think, where we've seen the most need. That there's just no solution that really solves that problem natively for an enterprise. And so most of our usage, a lot of our usage, has come from that narrower category of, this is a really, really hard multilingual use case, and nobody else has a product that can solve it for us.
Do you have some examples of like real life situations people or an organization are finding themselves in where they specifically need these different language capabilities? What does this look like in practice?
Yeah. I mean, the most obvious one is language learning. So if you're playing in Duolingo, and Duolingo is just an example in this case, but if you're on Duolingo, how do you learn the language? How do you learn a new language? There's something that you're familiar with. There's something that you're trying to learn. Oftentimes, there's syncopation to that. So maybe the app is evaluating your speech as you practice. You might be switching between different languages as you go through the process of trying to formulate a sentence. So I'm trying to say, I want to go to the library. Maybe I forget the word for library. So I say, I don't have another language that I would jump to, but I want to go to, what was that word? And then I'd say library in whatever language I was native in. Well, it's really handy as the AI application if you can capture both of those pieces, because the fact that the person code switched into their native tongue for a word indicates a gap in their understanding. And so that sort of kind of mixed utility, mixed language use is really critical for those sorts of applications, because the mixture encodes all of the information about what the learner understands or doesn't understand in the learning process. So that's just one. But there are others, meetings happen regularly in multiple different languages. So you might have, one speaker speaking in French and another speaker speaking in English, or some other combination. But having them in sequence and having a model that can understand that code switching is happening, rather than being something that breaks the behavior of the model, which is often what ends up happening in practice for smaller transcription solutions, is really valuable.
Super interesting stuff to think about. And it also brings me right back to this benchmarking study that you guys recently did, and how important speed and latency is in all of this.
So I think for a lot, because historically the pipeline has been how people instrument their speech applications, a lot of work is done into it, and it works, right? You need to keep latency on each of the stages. If you're going through these 3 stages, you have a speech to text, an LLM, and then text to speech. Generally, people want to keep the end-to-end time for those 3 pipelines. So how long it takes when the user stops speaking to when the agent starts responding, under about 2 seconds. And it changes depending on the application, but that's kind of roughly how much you can tolerate waiting before it feels painful as an end user to use the application. So you can imagine then how there's a cascading effect. If your text to speech side is a second, that's eating up half your budget for what you can accomplish. And oftentimes the LLM, if you're solving a hard problem, is going to be one of the slower components as well. So that's kind of like how you'd broadly be thinking about this, is what can I budget where? And as we move to bigger and bigger LLM models that potentially have longer latency between the fully transcribed request and then the response, that's going to eat more of that total budget. And so you need to get speed on either of the 2 other sides. You either need to get it on the text to speech and then hopefully in the speech to text, or figure out some other way. Maybe that means using a smaller LLM. The agentic flow, which is a single agent or a single model that provisions each of those steps, that knows how to internally coordinate each of the phases to get both from a speech in to speech out, allows you to be a lot faster. So in our benchmarks, our agentic model is 300 ms to start getting a streaming response back from the user. That's really, really fast. It's fast enough that the problem starts to invert, where it's almost too fast for some users, right? Like it's hard to know, are they done talking, right? Like the model can start talking before they've completed their sentence. And so then it becomes engineering work in some cases to I need to figure out when to start, because otherwise I'm going to get a response before the user's really ready for it. And this is especially true in language learning, by the way, as well, because again, the syncopation in the response, I'm thinking through what's that word mean, whatever else, so that maybe there's a long pause, but they haven't actually finished speaking because they're just thinking about what was the word for library, what was whatever else. So kind of broadly speaking, those are the 2 camps. And the problem with the agentic kind of model historically has been that one, the infrastructure wasn't built for it. So you didn't have all the same control levers. And that matters for complicated use cases. If you need some sort of compliance stage that happens against the user's request, well, what you can do if it's pipelined is, you hear the user's audio, you get a transcript of what they said, you send it through your compliance engine that checks before you do anything else. But that's much more difficult if it's an all-in-one, because you don't have an obvious lever to insert in the model that runs the compliance check before it starts producing an output. So that instrumentation piece is kind of still a problem where everybody's trying to solve. The second piece is that on the pipelines, historically the models are not as large, right? We're looking at LLM models that might be in that loop, which are now 1 trillion parameters, right? It's a very powerful model. The multimodal models have not historically been on that scale. And so their competency at really complicated tasks is oftentimes affected as a result.
So it sounds like, as we know, multimodal is one way, this cascaded pipeline is another way. There are people out there doing both. The pipeline model is kind of the the model, or the way of doing things that has existed. This multimodal is what you call kind of the agentic model. So both have their pros and cons right now, but it kind of sounds like what you're doing with Sprag and the multimodal way of doing this. Like so many ways that technology works have to shift in really big ways. And the ways that we've done things kind of sort of work, but there's this new way of doing things and you haven't figured out all the pieces yet, but nobody really has, is kind of my takeaway there. Because we see this in all parts, in all kinds of AI technology, not just the voice AI, and like what you're talking about.
I think we are seeing speech having its moment, which is why we're focused on it. But building on top of vLLM-Omni inherently gives us the opportunity to expand horizontally because of the broad set of modalities that we can serve. And so what I'm most excited about is solving all of these problems in speech and then being ready for the next moment, whether it's world models, video and audio input, video output, whatever it is, our infrastructure is built to be able to handle it. And so speech is what we're handling today, but we are really well positioned to be able to tackle problems as they come up next year, following year, 5 years from now. Diffusion models get better if they get better with text output. We'll be there to solve those problems as well.
We've already talked about some of the challenges that people face with the agentic model as opposed to the pipeline model. I think that there's going to be an enormous amount of value that comes from getting from 2 seconds or 1 second down to 500 milliseconds in a reliable way. And I think that agentic workflows agentic models of speech are likely to play an important role in that. So the question becomes, how do you facilitate the same capability set, the same tool calling capabilities, the same kind of instrumentation capabilities in a single model that you can currently instrument with a pipeline? So that's one of the things that we'll be working on kind of on our end over the next couple of years. And I think we'll start to change the way that people and businesses use AI and build their speech AI capabilities. And what that unlocks, I think, is like that's like the LLM, the AI whole story is that it's always a surprise what that unlocks in a lot of ways. You just don't know what does the shift from 1.5 second response to a 300 millisecond speech response. What does that unlock? I genuinely don't know. But I imagine robotics is going to be a really big piece of this moving forwards. And it's one of the places that we are very excited about multimodal inputs, in part because we think about like us, what does it mean to be an agent in the world? And we're taking in input from so many different dimensions: sight, hearing, sound, touch. All of these things are integrated, right? The mind is not an LLM that's getting some processed output in speech and then thinking about it and then producing something totally disaggregated from what you're seeing, right? Both of those things happen in the same time in the same model. And robotics is going to have something like that. So multimodal is going to be how you do that. And making those agentic workflows and those agentic capabilities fully integrated and seamless, right, is going to require these sort of capabilities to be fast and relatively performant, so that you can either put them on device or have them be fast enough that you can stream results to the robot locally. So I'm really excited about that. I think that there's going to be a lot of use cases, though, that we really just don't know. We're all just taking a guess.